Hello everyone. We're going to start with 8.8 is what this is going to be. I'll get to that in 1 second. The big idea of this whole unit is we're going to be evaluating limits. So the strategies I want you to use to evaluate limits are listed here on the board. You can write these down on some notes yourself. But when you ever see a limit, the first thing I'd like you to do is think of algebraic substitution. Now, when you plug it in, I'm going to show you, and you're going to have your packet, that if you get a number over 0, then the limit's not going to exist because it's a vertical asymptote like we talked about yesterday or the last time you watched this. But if you get 0 over 0, that means you're going to be able to simplify the function and plug in, which I'll give you examples of those. If for some reason you aren't able to do it algebraically, you can't figure it out, see if you can graph it. See if you can use a graph to figure it out. Now, if for some reason that doesn't work, you can always use a table, okay? So here's an example of using a table. If I ask you to find the limit as x approaches 0 of sine of x over x, if you plug in 0, you get 0 over 0. Well, you can try to simplify it, but say you don't know how to algebraically. You could use a graph, which I'll show you that in a second. But a table is always going to work. So remember, how do you do a table? You start with whatever x is approaching in the middle, and then you go 1,000th, 100th, and 1/10 in each direction. You plug these numbers in for x and see what you get. If you plug 0.1 in for x, the sine of 0.1 over 0.1, and make sure you're in radian mode, you're going to end up with 0.9. But if you plug in 0.01, you get 0.99. 0.001, that shouldn't be a negative there. Actually, those should all be negatives. I apologize. If you plug negative 0.1 in, negative 0.01, and negative 0.001, you get 0.999. Now, on the other side, if you plug in 0.001, you'd get 0.999. So as you can see, both sides are getting closer and closer to 1. Therefore, if both sides are getting closer to the same number, your limit exists, and it is 1. Now, if you graph this on a graphing calculator in radian mode, you're going to see that the graph looks like this. So graphically, what am I getting closer and closer to from the left and from the right? I'm getting closer and closer to a y value of 1. Okay, so review a little bit about how to do it by graph and how to do it by table, because we've had those. I gave you some homework problems. You can begin with those. So now what we're going to do is we're going to do 8.8, which is finding the limits as x approaches a number by the algebraic method. The next lesson, one of the next lessons, we'll be looking at it as, actually the next lesson is if x approaches infinity or negative infinity, we're going to actually treat differently. So if x is approaching a real number, that's what's going to happen. So I wrote you guys some rules. So finding the limit of a constant, if you're ever finding the limit as x approaches any real number of a constant, it's itself. The limit of a constant is the constant itself. This is true for one-sided or two-sided. And here's the idea behind it. If you have 7, that's just a horizontal line, isn't it? So no matter what x I'm looking at, which in this case is 2, if I'm looking at what x I'm approaching from the left and from the right, well, it's always 7, so I'm getting closer and closer to 7. So what's the limit as I approach 0 from the right side? Well, once again, the graph of 1/3 would look like this. So approaching it from the right, you're getting closer and closer to 1/3. So the limit of any constant is just going to be itself, because if you do your table, it's going to be 1/3 on each side the whole time. So it's going to be approaching 1/3 from the left and the right. All right. So when you substitute in, since there's no x, the limit of a constant is itself. But now if you ever have a variable in here, the first step I want you to do is to substitute the number in. If you get an answer, that is going to be your limit. So I substitute 2 in for x here, and I get my limit to be 2. So how do I find the limit as x approaches -1 of 3x minus 2? Well, I plug -1 in, and I get -5. So how do I find the limit as x approaches 3? Well, it's going to be 6 minus 3 is 3 over 4, so this limit is 3/4. Even if it's one-sided, your first step is going to be to plug it in. So how do I find the limit as x approaches 0 from the right side? Well, I plug it in. I get -1 times 2 squared, which is 4, so I get -4. And then finally, down here, Even though I'm plugging -2 in from the left, I plug it in. Well, on bottom, you get 5. And on top, you get 4 plus 4 is 8. 8 minus 3 is 5. So you get 5 over 5, which is 1. So if you ever want to find a limit and it's approaching a real number, the first thing you do is plug it in. And the only tricky part is if you ever have a constant, the limit of any constant is itself. All right? Sometimes it's not going to work out to where you plug it in and get an actual number. So there's two things that can happen. If you plug x in and you get a non-zero over a 0, then that means that there's a vertical asymptote there. You're not going to be able to simplify it. And I told you earlier, that's one of the reasons that a limit does not exist. So when I plug 0 in here, I get 6 over 0. So if I want to find the limit as x approaches 0 of 6 over x, I plug it in. If I ever get a number over 0, I immediately say it does not exist. Why? Because that means that 0 is a vertical asymptote. So as I'm approaching 0 right here, well, it's going down to -infinity up to infinity. I know the limit does not exist. Same thing here. When I put -1 in, I end up with -5 over 0. So in finding limits, your first step is going to be to substitute in. If you get a number, that's your answer. But if you happen to get a number over 0, you immediately say the limit does not exist. Okay? So now the other thing that can happen is you're going to get 0 over 0. If that's the case, you're going to be able to simplify. We're going to simplify the function, and then we're going to plug that into the new expression. So I'm going to take you back up here real quickly to show you. So once again, our big purpose is I want to evaluate limits. The first step is going to be algebraic substitution. If it's a constant, the limit of any constant is itself. But if you plug numbers in and you don't get an actual number, that means you're jumping down here to step 2. If you get a number over 0, you immediately say the limit does not exist because it's a vertical asymptote. But if you get 0 over 0, you're going to simplify and then plug in. So let's talk about that. What do I mean by simplify and plug in? So if I look at this and I said, okay, we'll talk about holes and vertical asymptotes later. Right now, let's just worry about the limits. If the limit as x approaches -1, when I plug it in, I get a 0 times a -4, which is a 0 on top, over -1 times 0, which is a 0 on bottom. So what happens is I get 0 over 0. That immediately lets me know that I can simplify it. It's not a vertical asymptote. One of the easiest ways to do it is factor the top and bottom and cancel out a factor. So now what my new thing is I'm looking at the limit as x approaches -1 of x minus 3 over x. Now I can plug -1 in here and I get -4 over -1, which is 4. All right, so first step in finding a limit is to substitute in. If you get a number, that's your answer. But if you get 0 over 0, that means you can simplify it. So factor out what you can. Well, most of the time it's not going to be nice and pretty with these factors. So let's look at letter B. If I said find the limit as x approaches 2 of x squared plus x minus 6 over x squared minus 4. Well, if you plug 2 in, you get 0 over 0. That lets you know you can simplify it. Well, the next step is, since they're going to be squareds, this is a trinomial and this is a binomial, see if you can factor it. Well, the top factors into x plus 3, x minus 2. And the bottom, this is a difference of squares, so it's going to factor into x plus 2, x minus 2. Well, when you factor out like this, you can see, hey, I can cancel out my x minus 2's. Now I can plug 2 into my new function, so I get 5 over 4. And that's going to be your answer. That is the limit. So let's look at the next one. The limit as x approaches -1. If you plug -1 in, you get 0 over 0. Some people may have issues factoring x squared plus x. Look, all you can do if you have two things with x's in it is take out the greatest common factor. You can take out an x out of each of those. Now you can cancel out the x plus 1's. Your new function is just x. So when I plug -1 in x, I get -1. Okay, so the next one. Here are the tricky ones. You're going to recognize this because you're going to see a square root in it. First step in finding a limit is substitute in. Well, if you put 9 in, you're going to get 0 over 0. That lets you know, hey, I can simplify this. There are two ways to simplify this, okay? The first way is, if you ever have a root, whether it's on top or bottom, multiply the top and bottom by the conjugate of whatever has the root in it. Now, only multiply whatever you took the conjugate of and itself, because on top, you're going to end up with an x minus 9, and on bottom, don't multiply it out. The reason being is, the reason why we're multiplying by the top and bottom is we want to cancel out one of the factors, okay? So when I multiply the top and bottom by the conjugate, you're going to cancel out the thing that didn't have the root in it. So when I multiply this to its conjugate, I get x minus 9. When I multiply this to this, well, I leave them apart. So now I can simplify, and my new function is 1 over the square root of x plus 3. Now I plug 9 in, and I get 1 over 3 plus 3, so my answer is 1/6. All right, so let's look at another one. The limit as x approaches 1 of x minus 1 over square root x minus 1. Well, when I plug in 1, I get 0 over 0. That alerts me that I can simplify it. But now, if I have a root x minus 1, I know that I can multiply the top and bottom by a root x plus 1 times a root x plus 1. Remember, don't multiply the factor that doesn't have a root in it. You leave it because that's what we're going to actually cancel out. And on bottom, when I FOIL this, I get an x minus 1. And now you can see we can cancel those out. Now I put 1 in here, I get root 1 plus root 1, which is 2. So that's one way to do it. The other way to do it, which is a little bit trickier, is even though this doesn't look like a difference of squares, we can make it be a difference of squares if we take x and make that be root x times root x. So you get root x plus 3 times root x minus 3. So you can actually factor x minus 9 into root x minus 3, root x plus 3. These cancel out. Plug it back in. You get the same answer. All right? So if you see roots, you can multiply the top and bottom by the conjugate. The reason why I do that method is because we end up rationaling all the time, practicing for the ACT and SAT. But here's another way you could do it. If you ever have a root, you can take what's not a root, and you can actually write this as a difference of squares with a root x as being your first lead term. And then what happens is you can cancel those guys out, you plug 1 in, and you get 2. Okay, so that's limits. Once again, how do we find limits? The idea to evaluate limits is we want to know the y value that my function is getting closer and closer to as x approaches a particular number. So if x is approaching a real number, you substitute it in. If you get a number, that's your answer. If you don't get a number, you're going to either get infinity over 0 or 0 over 0. If you get a number over 0, that means it's a vertical asymptote, so you can immediately write does not exist. Now, if you get 0 over 0, that means you can simplify it doing just like the ways we did. If for some reason when you get in homework, whatever, if you can't do it algebraically or if you can't simplify it, see if you can use the graph. And if that doesn't work, you can always use this table. Okay? The next lesson will be A9, and we're going to go over limits as x approaches infinity and negative infinity. And then we're also going to do one-sided limits and continuity. I don't know if I'm going to do them together or separate. We'll see. But anyway, if you have any questions, just ask me. And the homework I put on Google Classroom, just to let you know, I'll give you a quick snapshot of it. Sorry, it's in my beautiful handwriting. This is what you're doing. You did the 2 packets of the pre, you're doing the review and the multiple choice test, and then the next 2 weeks, you're doing A6 through A10, and then filling out the notes I gave you, and then doing the worksheets. Here's the problems for all of them. Now remember, this calculus book is on my Google Classroom. Sydney Worth has it under the comments. So just find it, go to 54, 1, 2, and 7 are tables, 9 through 18 are graphs. Okay, and then just keep moving on. You know, some of these you won't be able to do yet until you go over the A9 and A10, and I also go over some trig stuff with you. Okay, good luck. Let me know if you have any questions. Thank you.